The other reason that we don't like doing this is that I believe it is the violation of the D principle of solid. D principle is basically a dependency inversion. It says that high-level modules should not depend on low-level modules. I know that NavCompose is not much of a low-level module, but compared to our composable screen, it is in a lower level. And making our screen dependent on the NavCompose is not good, because when we pass the NavCompose to our screen, maybe in future we want to stop using NavCompose and use something else. We also need to modify each screen, because we are using the NavCompose directly inside our screens. Hello everyone, this is Puyan and welcome to my talk, Is Navigation Compose Bad for Your Health? So what should we expect from this talk? In this presentation, I'm going to talk about how to work with NavCompose. I'm going to talk about the challenges we faced working with Navigation Compose, and a spoiler alert, there's going to be a lot of ranting and whining about Navigation Compose. So if you're not interested in any of these three topics, I'm sorry for you. And if you're interested in any of them, I'm sorry for you too. You're stuck with me for the next 45 minutes. Before we start, I have a prologue here, I have 3 acts, and I have a resolution here. And I got a little bit melodramatic, and I want to turn my play into, turn my presentation into a play, like a theater or something. So if you know anything about cinema or theater or plays, please do excuse me. I have no idea. I just did it. So let's jump in. First, how to use Navigation Compose. Imagine that you have 3 screens. Starting from the left, the first one, list of pictures. So basically you see a list of pictures, you can tap on one of them, then the picture is open, you see the picture in full screen. There's going to be a like button, a comment button, and the number of likes. You tap on the number of likes, you go to another screen, which is basically the number of people who like the picture. And we're going to see how we can implement NavCompose for these 3 screens. So the first thing that we need is actually an activity, a plain simple activity with onCreate function, nothing special. The next thing we need is a NavController. How do we get a NavController? In our onCreate, in our activity, we use the setContent block to be able to access composable functions, and we just get a NavController from remember NavController. Pretty simple. What is a NavController? A NavController is basically responsible for these tiny arrows here. It gets us from one screen to another. You can look at it as a pilot for the whole system. The next thing we need is a Nav Host. How do we get a Nav Host? Again, in our onCreate, in the setContent, after having the NavController, we use the keyword Nav Host. And we just pass the NavController to it. We specify a starting destination, which is basically the address to the screen that we want to start with. And that's pretty much it. And I mentioned that the NavController is a pilot. The Nav Host can be the plane for the whole system. Now that we have a pilot and we have a plane, we need some destinations to navigate to. And the destinations are the nav objects, navigation objects. How do we create them? Again, inside our activity, onCreate, and inside our Nav Host, which we have a NavGraph builder between these 2 curly brackets in front of the Nav Host, we can use the keyword composable and create our nav objects. In the constructor, we pass a route, which is basically the address to this composable. And inside the building block, we can add any composable functions we want, which in our case, we are just initializing our composable screen and passing the NavController inside. That's pretty much it. This is the general working way with a Navigation Compose, and that's how we navigate. Inside each screen, we just call NavController.navigate, passing the address that we want. So that's pretty much it, how to use Navigation Compose. If you're still interested, I have 3 use cases here as 3 acts, but before we get inside the acts, let me tell you something about the background of my presentation. Well, there are 2 reasons that I'm using an iceberg as the background. The first one is that using Navigation Compose seems easy. As you saw, there's no complications in using it. But the more use cases we encountered, the more complicated it became for us. So I was like, maybe an iceberg with only the tip of it would do the job. The second reason, which is the more important one, is that this template was free, so I'm using this template. So yeah, let's jump into the first act. So we decided to start our first Compose feature. We decided that this feature needs its own separate activity. We decided that we are not going to use any fragments. We are only going to use composable screens, and as a result, we need Navigation Compose. So let's see how it worked out for us. You remember this beautiful illustration. I mean, sorry for that. There's a reason I'm trying to be an engineer, not an artist, as you can see. But we have 3 screens, a list of photos, a photo viewer screen, which is basically the full screen view of the photo, and a list of the liked pictures. They can navigate to each other, and each screen needs some data from the previous screen. Some string simple data like photo ID, owner ID, or the album name. And since we are using the navigation compose, we're like, okay, why not use navigation argument for pass this data around? And don't ask why we are not using the 10 other ways to pass data around. We just feel like using nav arguments. So at first, we decided to implement this without arguments to see if the actual navigation is working. So this is how we did it. This is how our Nav Host looks like. We basically decided to add 3 composables, 1 for each screen. So the first one, for example, the composable for picture list screen root, we just put the root into a constant and then initialize the screen inside it. And we also added 2 more composables for the other 2 screens. And that's pretty much it. We also passed the NavController down to each screen. So this is how we can navigate through our screens. We just call NavController.navigate passing the root. Everything is working. So let's move on to adding arguments. When we want to add arguments to our composables, we need to modify some small things. The first thing that we need to modify is the root of our composables. I don't know if it's visible. Yeah, it is visible. If you look at the root at the beginning of the file, there is a prefix, which is basically the name of the string, slash curly brackets, the name of the argument, slash curly brackets, the name of the argument, slash curly brackets, the name of the argument. And having all of this is mandatory. It is the way to declare arguments in your root. So yeah. The next thing is the arguments, which we declare we pass to the constructor of the composable. It is basically a list of nav arguments. If you look, for example, at this one, we are just creating a nav argument, specifying a name, specifying a type. It can be string type, integer type, boolean type, whatever you want, and also a flag for nullability. So we add 4 arguments here. And inside the building block, as you can see here, this is the way that we use the arguments we pass. We just do it.arguments.get a string or get integer or get boolean, whatever, and we pass it to our screens down here. Pretty simple. And after adding the arguments, it is how we navigate through our screens. Again, NavController.navigate, and passing the whole root and the arguments inside a plain string. So it is also working, and after adding all the arguments to our composables, this is how our Nav Host looks. So starting from line 48, adding arguments for composables, adding 2 other composables and arguments, ending at line 124 or something, which it is not visible here. But basically, we have 80 lines of code for 3 composables. Well, okay, it is fine as long as everything is working. But we are the kind of people that we get annoyed by a lot of things. So by this point, looking at this Nav Host, we were annoyed. And here's the list of the problems that we were annoyed by. First of all, there's too much code spamming our Nav Host. I mean, we only have 3 screens with some arguments. Imagine you have 6 screens. Imagine you have 10 screens. It's going to be 200 lines of code for just declaring your composables, nothing else. So it is annoying. The second problem is that there's no compile time type checking when you're passing arguments. Imagine that you're doing NavController.navigate, passing the root and some arguments in a plain string, and your arguments are the type of string, but you can pass anything you want, and nobody's going to check that. until your code crashes and you find out. So the compiler doesn't look at the root. And the third problem is that the URLs are really, or the routes to the screens are really prone to typos. So when you are typing navcontroller.navigate, passing the route, it's really easy to add two slashes back to back, or forget one slash, or forget a $sign or whatever. And again, you're gonna find out when your code crashes, when your app crashes actually, or maybe your code, doesn't matter. But anyway, you might be thinking that, okay, well, that's not big of a problem. You can just add a if statement on top of the nav controller and just validate the type of your arguments and put the root inside some constant. Well, yeah, the fix is really easy. But doing that, I mean, Nav Compose not checking that, it's basically leaving us humans, I mean, developers, which I guess we are humans as well, responsible for the error control. History has proven that humans are always gonna make a mistake if they have the option to do so. And since we are in a car museum, I have a really good example for that. I don't know how many of you know the brand Lincoln. I mean, not this guy, obviously. There's the brand car company Lincoln is a luxurious brand of Ford, the American cars. The cars are big, beautiful, I like them. I mean, they're not as good as Italian cars. You guys make the best cars. Definitely. But there's a model called MKC, which is ugly. I don't like that, but doesn't matter. The interior of this car looks like, this, okay. How do I zoom? Okay, yeah, I am a developer, yeah, but I don't know how to zoom. So there's this touch screen here. You can interact with your navigator, music, radio, whatever, and there are some buttons here on this dashboard. And the last one here is basically the button that you start and stop your engine with. So that's basically it. A button at the top and you have the touch screen. Imagine you're driving this car and you want to change the music or do something with the navigator. You do this, you reach out your touch screen while focusing on the road. All of a sudden you notice that you're slowing down. What happened? Your thumb or your other finger just hit the start and stop button and you shut down your engine. Again, you might be thinking that, okay, you're driving, pay attention when you're touching. True, but the problem escalated so much that actually, if you look at here, it says Ford is issuing a safety recall for approximately 13,500 Lincoln MKC vehicles to move the push button keyless ignition switch. Due to the close proximity to other controls, drivers are shutting off the engine while driving. So they recalled 13,000 cars just to move this tiny button from here to up here. I hope it worked out for them. But anyway, yeah. I believe that is the same kind of situation here. I mean, why would you leave us human responsible for this kind of error control? So enough with the ranting, and that's how we decided to fix the problem, actually. Well, the fix that we have here is not our original solution. We found something in one of the Google's code labs, which was not really easy to find, and I forgot to add the link here, but you can reach out to me and I will give you the link. But we were inspired by that solution, and the solution is basically creating a new separate file for each composable we have. In this separate file, we add three things. The first thing that we add, that you can see on the top of the file, is basically a constant for adding the root to that screen. The second thing is an extension function to the nav controller. This extension function receives nav options, which nav options is basically for having some animations to your navigation or some flags like pop back a stack or something. And we also pass the arguments that we want to use in the next screen that we want to pass inside this extension function. And inside the function, we are calling the navigate function and typing the whole URL and passing the arguments. Doing these two things, adding this extension function and this constant, we are already solving two problems. The first problem was that the type safety, when you're passing the arguments to this function, there's no way that you can pass the wrong type. I mean, if you have declared the right type in your function, it is always going to be the right type. So like this, we are making a natural compile time type checking, and that is perfect. And when we are calling the navigate inside this function, instead of typing navcontroller.navigate and the whole route every time, we are decreasing the risk of the typos because we are only typing it once and never touch this root again. We are calling the extension function to navigate. So we are already solving two problems. And the third problem, too much code in the Nav Host, we add a third extension function to the NavGraph builder, which basically we pass the NavController to it and we initialize our composable here instead of our Nav Host. And we call this extension function in our Nav Host. So our Nav Host is going to look like this. We went from 80 lines of code to 14, and we call 3 extension functions, one for each screen. They basically go and initialize our composable objects. So that's pretty neat. Doing that, our navigation will also look like this. In our screens, when we want to navigate, we use the new extension functions we made. We don't use NavController.navigate anymore. So yeah, that's pretty much it. And doing this, there's one downside to doing this, and that is that it creates a lot of boilerplate code. I mean, you have to do this for every composable screen and every composable node that you have. In the last Berlin's Droidcon, there was a talk about how to use KSP in a multi-module project and navigation compose. The talk was basically about having automatic code generation using KSP and having that doing all this boilerplate code. You can refer to it, maybe it helps you, but we don't have the time to go through it here. And that was basically our first act. In our first act, so far, we created a general system for NavCompose, and we decreased some risks and added some type safety. Now let's get to the second act. Well, where's my cursor? Okay. So previously on NavCompose, these beautiful screens, we had 3 screens. They can navigate to each other. They are passing some data. Everything is working fine. But there's something about this feature. Depending on how you interact with this flow, any of these 3 screens can be the starting destination. So basically, to say what the problem is that we have dynamic starting destinations. Each of these destinations can be used as a starting destination, and also they can be used as some node in our graph that can be navigated to, and they also need some data from the NavController as nav arguments. So when we are navigating to them using the NavController, we are just passing the data, easy. But when we are using them as the starting destination, I mean, there's no navigate function to pass the data to, and we decided not to type the whole route and pass the arguments in plain strings every time we want to navigate. So we are strict with using our extension functions that we created. So what should we do? How do we handle both? Before we go to the solution, great job forgetting about the animations, but yeah. Before we get to the solution, let me give you some context about the activity that we have for this feature. In our activity, we have 3 static functions. We basically create an intent and start the activity from previous screens. For example, if you look at this one, we are just creating an intent, putting the data that this particular screen needs, also putting the name of this screen, the starting destination that the activity should start with, and just starting the activity. So based on which screen we need to start with, we just call one of these static functions. It basically means that our activity knows which screen we want to start with, and our Nav Host is in our activity, so our Nav Host also knows which screen we need to start with. So the fix to the first problem, I mean the dynamic destinations, is that we just get the screen type from the intent, and if it's not null, which hopefully it is not, we pass it to the Nav Host. So pretty simple. Our Nav Host has dynamic destinations now. The only problem that remains is the data. We don't want to add something nasty here to this address, this destination, to pass the data. So we were like, okay, let's take a look at our nav arguments. Maybe they can be helpful. And yes, they were helpful. When we are declaring the nav arguments, we had a type, we had a nullable flag, and also we have this default value. This default value, what it does is basically that when you're using NavController.navigate and you pass some null amount for some argument, the NavController is going to come here, take a look at the default value, and if there's a value here, it is going to replace it with the null value that you passed. So we were like, since we are calling this extension function and the whole thing inside our Nav host, and we have all the data from the intent inside our Nav host, why not pass them to this function to have some compile time type checking, and also pass them to this default value, use them as the default value for our nav arguments. This way, when we are not passing any arguments, it means that we are using this screen as a starting destination, and it is guaranteed that we always have this data from intent. And whenever we are using it with the extension function for the navigation, we are passing the data ourselves. So in both cases, it is working. So we managed to fix that with the least amount of changes, and the only thing that we needed to do was to pass this data that we get from the intent to our extension functions and use them as the default value. Pretty simple. I mean, we didn't expect it to be that simple. It took hours of debugging and finding out the best way. So that's one of the reasons that I hate Compose. It already took so much time, but we are fine with it now. Yeah, everything was fine and was working. But again, since we are the type of people that get annoyed easily, we found something else that was annoying us. And that was nothing but passing NavController down to every screen. So yeah, in order to be able to navigate from one screen to another, having the NavController is necessary. I mean, how else can we navigate from one screen to another? But when you pass the NavController to every screen, you add a risk of tweaking the backstack from every screen. Each screen can call NavController.clear backstack or NavController.pop backstack or something like this. And trust me, it is going to take hours of your time trying to debug and find out who is calling what. I mean, it is basically an invisible problem. The other reason that we don't like doing this is that I believe it is the violation of the D principle of solid. D principle is basically a dependency inversion. It says that high-level modules should not depend on low-level modules, I mean, in short terms. I know that Nav Compose is not much of a low-level module, but compared to our composable screen, it is in a lower level. And making our screen dependent on the Nav Compose is not good, because when we pass the Nav Compose to our screen, maybe in future we want to stop using Nav Compose and use something else. We also need to modify each screen, because we are using the Nav Compose directly inside our screens. It is basically the NavController that we are making our screens dependent on. And the third reason that we didn't like it is that there is a principle, or maybe a common sense thing, called least privilege. What does this least privilege rule says? It says that when anything or anyone wants to do something, you must give it the exact amount of access that it needs, not a bit more. So for example, when a screen needs to navigate to two other places, we need to give it the exact amount of access to navigate to only those two places. Passing the whole NavController is basically like giving the control of the plane to some random passenger in the plane. So these are the reasons that why we didn't like it. Therefore, we decided to create some callbacks and pass the callbacks to screens instead of the NavController itself. So in our activity, we created a function like this for every navigation that we had. And inside this function, we are just returning the NavController.navigate function that we want, which here is navigate to album picture screen, for example, and having all the arguments. We are using the lambdas and all to make it possible. And we are just passing this function that you saw to the screen like this. For example, we have on view album clicked. We pass the function that we created. On picture liked clicked. We also pass the corresponding callback, and that's pretty much it. Pretty simple and way better than passing the whole NavController. And yeah, that was also basically it, our second act. So far, no, the wrong one. Callbacks, yeah. So far, we created a general system for navigation compose. We decreased some risk, added some type safety, learned how to have dynamic destinations, and also not pass the NavController around. And we are in the middle of our iceberg. Take a deep breath now. We are about to go inside the deep and dark parts of the sea. So, the third act. A new feature came in. My drawing got a little better, as you can see. And yeah, we are pretty much fast with our features, but don't tell this to our PO. I don't think he agrees, but anyway, that's what I think. So imagine you have a screen that has 2 buttons in it, nothing else. The first button leads you to one certain path, and the second button leads you to another path. So basically, you have 2 flows in this feature. I would like to call these 2 flows tap water screen and tap water flow and river flow. I got the feedback that they will become complicated somewhere in my presentation, but I didn't have time to change it, so please bear with me. Each of these flows had something like 8 screens, but the situation was that, the thing was that, both of those flows shared 3 screens. For example, if you look at the tap water flow on the left, it has amount of water screen, color of water screen, and taste of water screen. I mean, 3 specifications that water has. And the river flow has the same, has the amount of water screen, color of water screen, and also the taste of water screen. Having that, I was like, okay, maybe that's a good opportunity to use nested graphs, have one nested graph for each flow, and use one single composable into 2 nested graphs, well, avoiding duplication, using code. I mean, having reusable code is always good. So we created 2 separate navigation files for each NavGraph. The first one is for tap water flow. Again, we add 3 things: a constant for the route, an extension function to be able to navigate to this nested graph, and the third nested graph for the NavGraph builder. That is the block that actually initializes the nested graph. For creating a node in our NavGraph, we use the keyword composable, but for creating a nested graph, we use the keyword navigation, as you can see here. But everything else is the same. We specify a route for it, and we specify a starting destination, which is a dynamic one here. I mean, why not? We are the gods of dynamic destination now. And inside the building block, we call the extension functions that we created for those 3 screens. And we pass some callbacks to it. Pretty easy. We also did the same thing for the other flow, which is the river flow. Again, a constant, an extension function for navigation, and an extension function for initializing this nested graph. The same screens. It is basically the same extension functions that we created, so it is the same code. They had the same route, they had the same argument. The only thing that is different is the callbacks that we pass to each screen. So this one screen from one flow takes us to someplace else, and one screen from the other flow takes us to another place. That's the only difference, but everything else is the same. So we were like, okay, we are done with this, it should work. We just call these nested graphs in our Nav host, we initialize them, it must work. I mean, I personally did that 1,000 times with Navigation Compose for fragments, so it is not something unusual. We started the app, we started the feature, and we started with the first flow, the tap water flow. We saw the amount of water screen as the starting destination. Everything was normal. We tapped on next to see the next screen. We were expecting the color of water screen from the color flow. I know these names are pretty weird, but that's what I've got. So we were expecting the color of water screen from the current flow, but what actually happened was that color of water screen from the other flow that we weren't inside appeared. We were like, okay, maybe we passed some wrong route or wrong callback, but let's try it out with the other flow and see how it works. We tried it with the other flow, everything was working. So one of our nested graphs was not working, and we were like, yeah, that's probably it, the wrong route or wrong callback that we are passing. So we started debugging, but no matter how hard we looked at our code, we couldn't see any problem. At this point, I became a bit curious about how Nav Compose is working, and I was like, okay, let's take a look at how Nav Compose is implemented. Maybe it gives us an idea. So I started diving in, and it wasn't a pleasant experience, but I started with compose/navhost.kt. So we are looking at Android X navigation project. This is the actual code that Nav Compose is built upon. So when we use the keyword navhost and we initialize it in our screen, it is basically doing this. And the first method that it is calling is NavController.createGraph. So I started following the NavController. Going to the implementation and see what method it calls, it led me to this file, compose/navgraphbuilder.kt. This file basically, it was calling the keyword navigation, which is basically the keyword that we're using for creating nested graphs. In the building block of this nested graph, so it is coming to create our nested graphs, and the first thing that a nested graph does, it calls some function called addDestination. Again, I went to see how it is implemented, the addDestination. It was implemented in the same file, and what I found out is that a list exists in that file, which is basically a list of nav destinations, and this addDestination function is just adding the destinations to the list. Nothing complicated. But it means that the Nav Compose is creating the whole NavGraph the moment that you initialize the Nav Host. The NavGraph is not being built on demand. So the moment you initialize the Nav Host, Nav Compose already knows all the paths you have, all the nodes in the graph, and every navigation, every single navigation that you want to do. So I added some breakpoints here, and I noticed that our graph is healthy. It has 2 nested graphs. Every screen is at its own right place. Every route is right. So the problem is not in our NavGraph. The only thing that was left there for me to look at was the NavController.navigate function. That was something that we used to navigate through screens. So I started to looking inside the NavController.navigate. Diving inside it and following the method it calls, it led me to this file, navgraph.kt, and a method called matchDeepLink. So basically what happened is that when you call NavController.navigate, you are passing a route and some arguments to the NavController. It is going to take this route and the arguments, it is going to wrap them inside an object called navDeepLinkRequest. And using this method, matchDeepLink, it tries to find the best match in our NavGraph for the info that you provided. If we look at the implementation, the first line, there's a comment. First search through any deep links directly added to this NavGraph. So it is going through the graph, but apparently in a breadth-first manner. It is finding a best match. Then search through all child destinations for a match in deep link. So it is going through the graph again, but apparently in a depth-first manner. It finds 2 candidates, and it returns the maximum of those 2, I mean the better match of those 2. Again, adding a breakpoint here, I mean, it was a headache doing that. The debugger would have disconnected a lot of times, and I spent 10 hours maybe on trying to debugging that, but yeah, time not well spent. But anyway, I noticed that the best match, the first one that it finds, it is always the screen from the river flow. Doesn't matter which flow, but it is always one screen from one of the flows. And the best match is always the screen from the other flow. So it wasn't like it is choosing one of them randomly. I couldn't understand how it is choosing them, but the best match was always one of the screens from one particular nested graph, and the best child match was always the screen from the other graph. So we expected the best child match be returned when we are in tab water flow, for example, because the best child match was always the screen from the tab water flow. But adding a breakpoint here, I noticed that it is, when we are in the tab water flow, it is always returning the screen from the river flow. Basically, it is always returning the best match, which is at the left side of this method. So I became curious about how this max all null function is working. I went inside the implementation again. And the implementation is the collections.kt file. It is basically a simple maximum finding operation. It takes one node specified as max. It compares it to the next node. If it is smaller than the next node, it returns the next node as a new maximum. So having a breakpoint here, I noticed that max is one of the screens from the other flow, and E is another screen from the other flow. Basically, max is the first node, first candidate that it is going to find, and E is the next best candidate. So at the beginning of this act, I mentioned that we had 2 nested graphs, and we used the same composable object into both nested graphs. So the code for this maximum and E nested nav destinations are the same. The routes are the same, the arguments are the same, basically everything is the same. So the situation here is that it is comparing something with itself. it definitely is not going to be smaller than itself. So it is always going to return false, and as a result, it is always going to return the first one, which is the max, as the result. But I went to see how this comparison argument is implemented for nav destinations. I mean, there are not numbers that you can easily compare them, so there must be something. Digging deep inside the code, I found in navdestination.kt file the compare to function overridden. Compare to is basically when you use the comparison operator, it is calling the compare to function for nav destinations. We have 4 parameters here. We have matching args, is exact deep link, has matching actions, and MIME type match level. We don't have time to go through details about what these are, but I can assure you that none of these is related to the composable's parent. They are all related to the composable's itself. And since it is comparing 2 nodes, it is trying to return a 1 or -1 here as the bigger or smaller, but it can't because they are the same. None of them is bigger. It comes down the decision to this line of code, which, oh, what did I do? Okay. Which basically is dedicating the MIME type match level from the other node's MIME type match level, which it is basically an integer. And it is, imagine that it is 1 for both of the screens. It doesn't matter what it is, but it is one of the specifications of the nodes itself. So the result of this is always going to be 0 because you're dedicating a number from itself, which means that the result of this comparison is going to be 0, which means that our problem is that NavCompose is not paying attention to the nested graph that we are actually in. When it is trying to find the best match, it is only comparing the nodes with each other. Yeah, it was this slide. So when you ignore the nested graph that we are in, it is what it happens because we are using one composable object in both nested graphs. I mean, how can you decide which one is better? So the solution was that we had to duplicate our code and we had to create another composable object with everything same but the different root and add it to another nested graph. So for each nested graph, we finally had to create 2 composables with 2 different roots. This is something that, as I said, I've done a lot of times with nav component for fragments. Adding 1 fragment to 2 nested graphs, probably there was some code generation under the hood that was handling this. But in NavCompose, there is no option to use 1 composable into 2 nested graphs, only because that it is not considering the nested parent graph that we are in. I added an issue for this problem at the issue tracker. If you search for nested graph in Google's issue tracker, you're probably going to see my issue. There are some conversations going on in this issue, but I hadn't had the time to update it in the past few days. But I hope something good comes out of it. And yeah, that was pretty much the 3rd act. A lot of hours spent to find out that, yeah, we finally need to do a copy-paste and change a route. But let's get back to our actual topic. Is Navigation Compose bad for your health? Thank you so much, everyone, for listening.